The production of the Excavator 6015 typically refers to a large-scale machine, commonly manufactured by major construction and mining equipment companies such as Caterpillar, Komatsu, or Volvo. The process for assembling such machines in a factory or assembly plant involves several detailed steps. Here's an overview of how the production process could unfold for an excavator like the 6015 in an assembly plant. 1. Component manufacturing and sourcing. Engine. The heart of an excavator is its engine. The production begins with sourcing a powerful engine that meets the required specifications for the machine's operation. Hydraulic system. Excavators rely heavily on hydraulic systems to operate their arms and attachments. The hydraulic pumps, valves and cylinders are designed and fabricated separately. Steel frame. The main structural elements, such as the undercarriage and the upper structure cab, boom arm, and other body parts, are constructed from high-strength steel. Tracks. Heavy-duty tracks, or wheels, are produced for the undercarriage of the excavator to ensure smooth movement over rough terrain. 2. Sub-assembly. Undercarriage. Assembly. The undercarriage, which includes the tracks and drive components, is assembled first. It is a crucial component for the movement of the machine. Hydraulic system. The hydraulic system is pre-assembled, including cylinders, pumps, and control valves. It is tested for fluid flow and pressure before being sent for integration into the main body. Cab assembly. The cab, where the operator controls the machine, is designed for comfort and efficiency. Inside the cab, controls for the hydraulic system, engine management, and other operations are integrated. 3. Main assembly line. Chassis and body assembly. The frame and other components like the boom arm and counterweight are brought together on the main assembly line. Engine and hydraulic integration. The engine is placed into the frame, while the hydraulic system is integrated into the boom and arm of the excavator. Electrical system. Wiring for lights, sensors, control systems, and other electrical components is routed through the body and cab for quality control and testing. Engine and hydraulic testing. The excavator's engine is run to verify performance under load, and the hydraulic systems are tested for leaks and proper function. Movement testing. The machine is tested for proper movement, with the tracks running smoothly and all the mechanical parts, such as the boom, arm, and bucket, functioning correctly. Safety features. Features like emergency stop systems, operator safety mechanisms, and stability control are tested. 5. Finishing and inspection. Cosmetic finish. The excavator is painted with high durability paint to protect it from environmental elements. Branding and markings are added. Final inspection. A comprehensive inspection is conducted to ensure the machine meets quality standards before being dispatched for delivery. 6. Shipping. Once fully assembled, tested, and inspected, the excavator is prepared for shipping to the dealers or customers, either by road, rail, or sea, depending on the destination. Excavator models like the 6015 are usually aimed at heavy-duty construction and mining operations, so they undergo rigorous quality checks and are built to last in tough environments. Each component is critical to ensuring the excavator's operational efficiency and longevity. Great! I'm glad the overview helped. To give you an even deeper dive into the production process of the Excavator 6015, or similar models, let's break it down further. 1. Component manufacturing and sourcing. Engine production. The engine in these large excavators is designed for maximum power and efficiency. Typically, these engines are produced by companies specializing in high-performance engines, like Cummins or Caterpillar's own engine manufacturing. The engine includes key parts such as pistons, crankshafts, and cylinder heads, which are machined to precise specifications to ensure reliability during operation. The engine's cooling system, exhaust, and fuel delivery systems are also designed for optimal performance in demanding environments. Hydraulic components. The hydraulic pumps, motors, and cylinders are integral to the excavator's operation. These systems are produced in dedicated factories, where each component is assembled, pressure tested, and optimized for durability. Hydraulic systems are often designed for high flow and pressure, allowing the excavator to perform tasks like digging, lifting, and rotating with ease. Tracks and undercarriage. Tracks are typically made from steel links that are hardened to withstand wear, especially in harsh environments. Manufacturers use computer-aided design CAD to model the track links for maximum durability. The undercarriage also includes rollers, idlers, and sprockets, all of which must be designed for easy replacement and maintenance. 2. Sub-assembly and quality assurance. Undercarriage assembly. workers or automated systems begin assembling the undercarriage. The process involves fitting the sprockets, rollers, and track frame together. Once the undercarriage frame is complete, it is subjected to testing for stress, load-bearing capacity, and functionality. Boom and arm production. The boom and arm, which are responsible for the excavator's lifting power, are welded from high-strength steel plates. These parts are meticulously welded to withstand the stress of daily operations. Hydraulic cylinders are installed on the boom and arm during the subassembly process, and each cylinder is individually tested. 3. Assembly line and integration. Main assembly. As the parts come together on the assembly line, components like the boom, arm, and bucket are attached to the undercarriage. This is a highly precise step as the alignment must be perfect for the excavator's performance. The drive components, including the engine and transmission, are mounted next. These systems are usually pre-tested to ensure they function seamlessly with the excavator's hydraulic system. Electrical and control systems. The excavator's control panel is installed, with all wiring and electronic components routed through the vehicle. This includes the engine management system, EMS hydraulic controls, lighting systems, and sensors. More modern excavators may include telematics systems, which provide real-time data on the machine's performance, location, and maintenance needs. For testing and performance verification. Hydraulic testing. Once the hydraulic system is connected, it is tested for fluid leaks, performance, and pressure regulation. The various hydraulic components such as the boom, arm, and bucket are tested for range of motion and ease of operation. Movement and functionality test. The excavator is powered up and its movement is tested, including its speed, stability, and turning radius. Every aspect, from lifting capability to boom extension, is closely monitored. Load testing. A crucial aspect is load testing to ensure the machine can handle the operational stress it is designed for, especially when lifting heavy materials. Final inspection. Before the excavator is deemed complete, the machine undergoes a final inspection to check for small details such as electrical faults, visual imperfections, and overall machine quality. The serial number, certifications, and documentation are finalized. 5. Delivery to market. Customization. Many companies offer customized features, such as different bucket types, extended arms, or specific attachments for unique tasks, like forestry work, demolition, etc. Shipping. Once all tests are passed and quality checks are cleared, the excavator is prepared for shipping. Depending on the region, these machines are either transported by road, rail, or by large containers for sea freight. 6. After-sales support, maintenance, and service. Manufacturers offer detailed maintenance manuals and have dedicated teams for repair and parts replacement. Regular maintenance is key to prolonging the machine's life and ensuring its optimal performance. Software updates. Modern excavators like the 6015 might also be equipped with software that can be updated remotely. This ensures the control systems, performance metrics, and telematics are always current. Awesome. Let's dive deeper into each of the major stages of the production process of an excavator like the 6015. 1. Component manufacturing and sourcing. Engine production. Precision manufacturing. Excavator engines, like those used in the 6015, are built for heavy-duty performance. These engines typically have high torque ratings to provide the power necessary for large tasks such as digging and lifting heavy materials. Manufacturing process. The engine parts, pistons, crankshafts, cylinder heads, are manufactured using precision machining techniques. After being created, parts are treated to enhance their durability, hardening or coating to resist corrosion. For instance, testing and quality control. Every engine is tested for fuel efficiency, emissions control, and performance under load. After the engine is installed in the excavator, the system undergoes rigorous testing to ensure no leaks and optimal power transfer. Hydraulic system. Manufacturing. The hydraulic system is one of the most important elements in an excavator, responsible for controlling movement of the boom arm and bucket. Components like hydraulic cylinders, pumps, and motors are carefully manufactured with high-strength materials to handle high pressures. Hydraulic pumps. The hydraulic pump is designed to convert mechanical energy from the engine into hydraulic energy, powering the movement of various parts. Its efficiency directly impacts the machine's performance. Pressure testing. These components undergo Pressure testing to ensure they can operate at the required levels without leaks or failure. In some cases, they might be subjected to multiple testing phases before being certified for use. Tracks and undercarriage. Manufacturing tracks. The tracks used in large excavators are made of heavy-duty steel and designed to resist wear from rough, rocky terrains. Each track link is precision machined and hardened to avoid quick wear. Undercarriage. The undercarriage components, including rollers, sprockets, and idlers, must be precisely manufactured and designed for easy maintenance, as these are parts that wear out more frequently due to the abrasive environments excavators operate in. Testing. Before installation, each track assembly undergoes a rolling test, simulating the heavy loads and motion patterns of the excavator under working conditions. 2. Subassembly and quality assurance. Undercarriage assembly. Frame welding. The undercarriage frame, which supports the machine's weight and helps with mobility, is welded from high-strength steel. This is a critical stage, as the frame must be square and true for the machine to function properly. Rollers and track installation. The installation of the rollers, idlers and tracks occurs next. The rollers must be fitted correctly to minimize resistance and wear. Each track link is then installed, and the track tension is carefully adjusted to ensure smooth movement. Boom and arm production. Welding and fabrication. The boom and arm of the excavator are fabricated from large steel plates that are welded together. These parts must be designed to withstand significant stress, as they will carry heavy loads during operations. Hydraulic cylinder integration. The hydraulic cylinders are attached to the boom and arm to control their movement. These cylinders must be tested for smooth operation and durability, ensuring that they can handle both lifting and digging operations without failure. Comfort and safety. The cab, where the operator sits, is designed for comfort and safety. It is often built with soundproofing materials and ergonomic seating to reduce fatigue during long hours of operation. Integration of controls. All control systems, including joysticks, levers and pedals, are installed and calibrated. The electronic systems, including displays for monitoring engine performance, fuel consumption, and machine health, are tested and integrated. 3. Assembly line and integration. Main assembly line, main chassis and body integration. The undercarriage tracks, rollers, and frame is brought into the assembly line first. The next major step is the integration of the boom arm and counterweight, boom, and arm attachment. These components are heavy and must be lifted into place using cranes or other specialized equipment. They are bolted or welded to the undercarriage, depending on the design specifications. Engine mounting. The engine is installed next. Care must be taken to ensure that it is correctly aligned with the hydraulic pumps and drive systems. Test runs for functionality. After the engine is mounted, initial functionality tests are performed, ensuring that power is being correctly transmitted through the drivetrain and hydraulic pumps. Electrical and control systems. Wiring and sensors. Wiring harnesses are installed to connect the control systems, safety features, and engine management. Modern excavators have multiple sensors that monitor everything from fuel levels to exhaust emissions. Control integration. The machine's control system is now integrated. This includes the software for the engine management system, hydraulic controls, and telematics for real-time performance tracking. Calibration. After installation, systems like joystick controls are calibrated to ensure that the operator can control the boom, arm, and bucket with precision. 4. Testing and performance verification. Hydraulic testing. Hydraulic system testing. The hydraulic system is powered up and tested to ensure smooth operation across the boom, arm, and bucket. If there are any issues with fluid leakage or pressure inconsistencies, the system is fine-tuned and retested. Load and stress testing. Simulated working conditions. Load testing is performed to simulate real-world tasks. The excavator is loaded with heavy weights to simulate the digging and lifting tasks it will face on site. Stability check. The stability of the excavator is assessed by testing its lifting and digging abilities in different positions. It's critical that the machine is stable under all expected operational conditions. Final inspection. Mechanical and electrical inspection. Each component is checked for proper assembly, including the engine, hydraulic components, and structural integrity. Paint and finish check. Once everything is functioning, the excavator is checked for any surface imperfections, and the finished paint, decals and logos is applied and inspected. 5. Delivery to market. Customization. Attachment options. Depending on the intended use, for example, digging, lifting, demolition. The excavator may be customized with different attachments like hydraulic hammers, quick couplers, or buckets of varying sizes and types. Shipping, transport, preparation. After the machine is fully assembled, it is carefully prepared for shipping. For international markets, excavators are often disassembled slightly to fit into shipping containers. Transportation methods. The excavator is then shipped by rail, road, or sea, depending on the destination. The shipping process requires careful handling to avoid damage during transit. 6. After sales, support, maintenance and service. Scheduled maintenance. Manufacturers provide owners with a maintenance schedule, which often includes routine inspections, fluid changes, and parts replacements at specific intervals to ensure longevity. Repair services. Authorized service centers provide repair services for any failures that may arise during operation. Many manufacturers offer extended warranties for parts and labor. Software and telematics. Remote diagnostics. Many excavators come equipped with telematics systems, allowing owners and fleet managers to monitor real-time data on machine health and performance, including fuel consumption, engine diagnostics, and maintenance schedules. Software updates.